Today, we're pulling back the curtain on something you probably never even think about, but rely on every single day. We're talking about the invisible shield that protects our homes from the rain. I mean, seriously, think about it for a second. When there's a huge downpour, tons and tons of water are just pounding on our buildings. And then, a little while later, it's gone. It doesn't just disappear into thin air. Nope, it's being whisked away by a really, really smart system. But before we get into how it all works, we've got to understand the why. Because, without a system to manage it, rainwater isn't just a minor annoyance. It's a real, genuine threat to any building. See, if you just let all that water soak into the ground right next to your house, it can actually weaken the soil holding up the foundations. That is not good. Plus, it can create these nasty stagnant ponds, which are just breeding grounds for all sorts of gross stuff. So the bottom line, you absolutely have to control this water. It's a complete non-negotiable. And the answer, the solution, is a purpose-built, fully engineered system designed to catch every single drop and guide it somewhere safe. This isn't just a bunch of pipes, you guys. It's a building's first line of defense against Mother Nature. So where does this whole battle against the rain even begin? Well, it starts right at the top. The roof is the front line. It's where all the most important work of collecting that water happens. Now, for most of the houses we see, the ones with the sloped roofs, the game plan is pretty straightforward, but it's also incredibly effective. You use gutters to catch the water as it rolls off the edge, and then you use downpipes to bring it down to the ground. Simple, right? Okay, now this is where it gets really cool because not all gutters are created equal. For smaller buildings, you've got your standard eaves gutter. And get this, it's installed with a tiny, tiny slope, about 1 in 350. It's just enough of a tilt to get the water moving, but it's so subtle you'd never even notice it. For taller buildings, they use parapet gutters, which are tucked away behind a wall to make them safer to clean. And then you have these heavy-duty valley gutters, built to handle a ton of water where two different parts of a roof meet. And this slide just perfectly lays out how the strategy completely changes depending on the roof. A pitched roof, well, it uses good old gravity to send water right to the edge for collection. But a flat roof has to be a little sneakier. It has a slight slope or a fall engineered right into its surface to guide the water towards a drain. It basically acts like a giant super shallow funnel. All right, so the water's made it off the roof. Job done, right? Nope, not even close. Once those downpipes deliver the water to the ground, the system's job is far from over. Now it's time to manage all of it in open areas like driveways or courtyards. And there are two main plays you can run here. The first is pretty simple. You just slope the whole surface ever so slightly so the water naturally flows away toward the street drains. The second, more heavy-duty approach is to build an entire underground network of channels and drains that collect the water right there and then pipe it away. And that underground system isn't just some standard pipe they picked up from the hardware store. Oh no, engineers have this whole toolkit of different channel types to choose from, depending on what the site needs. You've got your classic U-shaped channels, big rectangular concrete ones. Each one is picked for a very specific job. The materials have gotten a major upgrade over the years, too. Back in the day, these systems were made from super heavy but really durable cast iron. But now, PVC is way more common. And why the switch? Well, it's lighter, it's way easier to install, and it needs a lot less maintenance, which saves everybody time and money in the long run. Okay, buckle up, because this is my favorite part. This is where you see the real genius behind the whole system. None of this is guesswork. The size of every single gutter, every single pipe, is figured out using precise scientific calculations to make sure the system can handle a worst-case scenario storm. So to design one of these systems, engineers have to play detective. They're asking all these questions. How hard does it really rain in this area? What's the total surface area of the roof we're dealing with? Do we need to account for wind? What about water running down the walls? All of these different factors get plugged into a formula to find one critical number. And that magic number is called the flow load. This is the single most important calculation. It tells you the exact volume of water, down to the cubic meter per second, that the drainage system has to be able to carry away during the heaviest possible storm. It's the system's max capacity. And the math to figure it out? Actually, it's not as scary as you might think. It's basically a simple 3-step recipe. You take your roof area, you multiply it by the local rainfall intensity, and then you just divide that whole thing by 3,600 to get the flow rate per second. Okay. Theory is great, but let's put some real numbers to this to see how it works. Let's imagine a pretty average roof, about 50 square meters. in a place where the heaviest rain they ever get is 75 millimeters an hour. You crunch those numbers, and boom, there it is. Now, that might look like a tiny little decimal, but what it means is that the system has to be designed to handle 1 full liter of water every single second. Every piece of that system is sized to manage that exact flow. That is not guesswork, folks. That's engineering. So when you put all these pieces of the puzzle together, the gutters up on the roof, the channels buried in the ground, and all the precise science that goes into sizing them, you really start to see the whole picture, don't you? I mean, the source material just puts it so perfectly. This isn't just a nice-to-have feature, it's absolutely essential. It's what keeps buildings safe and structurally sound, and it's what keeps the areas around them sanitary. So you see, we're not just talking about plumbing here. These are more than just pieces of PVC or metal. They're all parts of a silent, sophisticated, and beautifully engineered shield that stands guard over our homes 24/7. So, I'll leave you with this question. The next time you're all cozy inside during a big storm, listening to the rain come down, will you just hear water? Or will you be able to picture that invisible shield, that whole complex system, humming along, working hard to keep you safe?